Okay, so on our warm up here, we're shading in the angles. So angle ABC. Where's angle ABC at?
It's at that corner where B is. Top right corner.
Okay, it's where B is at. It's the whole thing there, right? Mm-hmm. Because A, B, C fills up that whole thing. Okay, number 2, where's angle BCE at?
It's half of the angle of C.
Okay, it's half of this angle right here at C. It's this right here. Okay, good. So we have BCE. It's that angle right there. Okay, where's angle BEC?
It's right in between B and C. It's in the middle.
Okay, good. So it's this angle right here. That's right. It's BEC, like that. Okay, ADB.
It's half of the angle D.
Okay, it's half of this angle D right here. Okay, ADB. Okay, where's AED?
It's on the bottom left corner.
Okay, so it's this one right here. Alrighty. And then number 6, BCD. This one's the whole thing of C, right? Because BCD is like this, so it's this whole angle here. Okay, so what we're doing today is we are basically reviewing the properties of quadrilaterals that we've been doing since last Thursday. So over a week on doing this. What we're going to do today is just review just this part basically. Then on Monday, we're going to have the full unit review. And then on Tuesday, as you can see over there on the board, you're going to have your test. Okay? So test will be next Tuesday. All right. Now, again, like I said, this goes all the way back to last Thursday. But we're going to first, in this first box, talk about these 4 properties of parallelograms. So in this first one, what do you think this property is talking about right here?
The first one, the sides. Two parallel sides.
Okay, so we're going to say it like this. That's right. All right. Opposite sides congruent. Okay, opposite sides are congruent. What do you think that second one there is talking about? Opposite angles are congruent. Okay. Opposite angles are congruent. So like F and H are congruent to each other, G and J are congruent to each other. Okay, what is this third one talking about? What does it say?
Each angle adds up to 180.
Okay, what's the word we use for this? It's a weird word, we don't use it very much. Starts with the C.
Congruent.
Congruent's close, but that's not it.
Constant.
Closer. Means like one after the other. Consecutive. There you go. Good job. All right. Consecutive angles are supplementary. Remember, consecutive means like one after the other, in order. So like up there saying like F and G add up to 180. F and G are consecutive angles. They're right next to each other. Okay, and then what's that last one? That last property, main property of a parallelogram. What does? What do you call this that cuts across her like this?
Median. Halfway point. Midpoint.
Nope. What do we call that line that cuts across there?
It starts by C now? Perpendicular.
What do we call that?
What does it start with?
Starts with the D.
Diagonal.
Diagonal. There you go. All right, good. So the diagonals bisect each other. Diagonals cut each other exactly in half. Diagonals bisect each other. So those are the 4 main properties of parallelograms. There's other stuff, but that's the main thing. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, and diagonals bisect each other. All right, next is rectangles. There's just a couple things here. So really this first one is just basically the definition of a rectangle. So it's a parallelogram first, then what's the other thing that makes it a rectangle?
4 right angles.
Good. It's got 4 90-degree angles. Okay, rectangle is a parallelogram that has 4 90-degree angles. Okay, so that's kind of the definition of it. Then we just have one property here. So in a rectangle, what's up here? Good, diagonals are congruent. In a rectangle, the diagonals are congruent. All right, next is property, and whoever did this misspelled that, but it should be properties of a rhombi, properties of rhombuses, okay? So on this first one, it's basically just, again, the definition of a rhombus. So first of all, it's a parallelogram, but what makes it a rhombus after that? Good. 4 congruent sides. 4 congruent sides. So that's just kind of the definition of it. These other two are properties. So in a rhombus, what's that second one talking about?
Bisects make a 90-degree angle.
Okay, not bisect. What's the word? Okay, diagonals, you're right. But the diagonals are what? It's a big word. Make 90 degrees. What is that word?
No, they're complementary.
Well, complementary means they add up to equal 90. Yeah, but when two lines cross each other to make a 90-degree angle, what do we? Perpendicular. There you go. Okay, so in a rhombus, the diagonals are perpendicular. They make 90 degrees. Okay, and then on this last one, in a rhombus, the diagonals bisect the angles. Cut the angles exactly in half. Okay, next, talking a little bit about kites. So this first one is just the definition. So in a kite, it's a quadrilateral that has 2 pair of consecutive congruent sides. Two pair of consecutive congruent sides. So what that means is these two sides that are consecutive right next to each other, they're congruent. And then these other two sides are consecutive, they're congruent to each other. All right, so in a kite, the diagonals are perpendicular, just like in a rhombus. And then the second thing is here, there's only one pair of congruent angles. Okay. On the back, trapezoids. So this one's basically the definition. So a trapezoid is a quadrilateral with only one pair of parallel sides. It only has one pair of parallel sides. So a trapezoid is not a parallelogram because only one set of sides is parallel. The other two are not parallel. Okay, then what I had in mind here is this is an isosceles trapezoid. So it's an isosceles trapezoid because that side is congruent to that side. So in an isosceles trapezoid, the diagonals are congruent. And then this last thing right here is just the mid segment. So let's say that this is 20 feet and this is 28 feet. How long is the mid segment going to be? 24 feet. That's right. It's a number exactly halfway between those. And remember, if you forget that, you can just add them. 20 plus 28 divided by 2, and that'll give you that 24. Okay, I'm going to drop down here to this little bubble map thing. All right, so at the top here, we're going to put quadrilaterals. Okay, so quadrilaterals. So what are different quadrilaterals we've talked about? Okay. Okay, yeah, let's go ahead and do that one. So that's going to fit right here. Parallelograms. Okay, and then we'll finish up underneath the parallelograms in just a second. But what are the other quadrilaterals that we've talked about that are not parallelograms? Okay, trapezoid is one. Okay, good. So trapezoid is one type of quadrilateral, and then within that, a specific type of trapezoid is an isosceles trapezoid. And then what was the other thing we talked about that? Good. That's a quadrilateral that's not a parallelogram is a kite. Now, underneath parallelograms. Okay, good. So we have a rhombus and a rectangle. Our parallelograms. Good. And then that brings us all the way down to a square. Okay, good. Now let's jump up here. I'm not necessarily going to work these out. I just want to remind you how to set these up. Okay, so this is a parallelogram right here. And so to find W, what do I know about these two sides right here? They're congruent to each other. So we would set 4W plus 8 equal to 5W plus 1. And again, I'm not going to go through the steps of working that out, but if you subtract 4W, that leaves 1W. Subtract 1, that leaves 7. So W equals 7 on this one. Okay, let's say I wanted to find the value of Z. What do I know about these two angles right here? Okay, good. These two add up to 180 because those two are consecutive angles of a parallelogram, so they're supplementary. So on this, it's going to be 9Z minus 12 plus 3Z equals 180. And again, I'm not going to go through all that, but add your Z's, you get 12Z, then add the 12 to the other side. So 192 equals 12Z divided by 12. Z equals 16 on this one. Okay, I want to look at this one. So this says this is a rhombus, and we're looking for the measure of angle MKL, which is right here. All right. Now, since this is a rhombus, the diagonals bisect the angles, so they're all congruent all the way around. So 65, 65, 65. And this angle right here in the middle, 90. Good. The diagonals are perpendicular, so this is 90. So how am I going to find this angle right here now?
180 subtracted by 90 subtracted by 65.
Good. So I'm going to take 180 minus 90 minus 65. And that leaves 25 degrees. Okay, so we are about to go out in the hallway, work on some of these problems.